Material flow analysis, also known as MFA, has become a useful tool for industrial ecology to analyze the metabolism of social systems. Material flow analysis is a systematic assessment of the flows and stocks of materials within a system defined in space and time. It can quantify and assess materials including goods, elements, and compounds. MFA connects the sources, the pathway, and the intermediate, also the final sinks of a material.
So, what are the objectives of MFA? First, it is used to trace the flow of raw materials, to retrace waste and emissions, to set for appropriate measures, to manage resource, the environment and waste, and also to identify inefficiencies.
There are two types of MFA, Type 1 and Type 2. For the Type 1, it includes the impact per unit of the substance, such as carbon dioxide from manufacturing industries, vehicle combustions, and from the manufacture of aerosol sprays and refrigerants, as well as the impacts per unit of material, such as plastics and biomass, and the impact per unit of products, such as diapers and batteries. It is used within firms, sectors, or regions. As a result, Type 1 MFA can be used to develop environmental policies for hazardous substances. As for the Type 2, it is a throughput of firm, sectors, and region. It includes the throughput of firms such as from the plants and medium and large industries, as well as the throughput of sectors, such as in construction and production, and the throughput of region, such as the total throughput and the total material requirement. It is associated with substances, materials, and products. As a result, Type 2 MFA is usually used in providing the firm environmental performance data.
Have you ever considered using MFA in a simple process like making French fries?
Firstly, the harvester machine is used to harvest raw potatoes from the potato farm. Then, the raw potatoes will be thoroughly washed to remove the dirt and grimes. After being washed, the potatoes will be sliced according to the desired thickness. The potatoes will then be soaked in water for at least an hour or overnight to remove the starch. Rinse them twice with cold water before patting them dry. The sliced potatoes will be then fried for about 5 or 6 minutes at 300 degrees Celsius, and they must be fried in batches to be crispy until it turns golden brown. Finally, the French fries are ready to be served with ketchup or chili sauce, if preferred.
The input used for making French fries includes raw potatoes, water, and cooking oil, while the output from the process are potato peels, wastewater, potato that have been fried, and leftover of the cooking oil. The table shows the quantitative information of making French fries and also consists of its value for the input and output of the materials. The data is collected by weighing and measuring as well as by accounting analysis. The mass value for both input and output must equal to indicate the total mass of the material that has been used and its total waste produced. To visualize more about the material flows from the process, a Sankey diagram can be used.
Next, what is a Sankey diagram? A Sankey diagram is a method of visualizing a change in values from one set to another. Nodes and links are the term used to describe the connected objects and connection. It is frequently used in material flow analysis because it can visually depict material and mass flows. For example, the food processing of French fries. This is the Sankey diagram for French fries processing. From the Sankey diagram flows, we can determine the efficiency of making French fries.
Okay, now let's move on to environmental accounting. Environmental accounting has many meanings and uses. However, for this topic, it means the application of environmental accounting as a managerial accounting tool for internal business decisions. Moreover, environmental accounting revolves around environmental costs, which can mean private costs that refer solely to costs that directly impacts a company's bottom line, or societal costs that encompasses the cost to individual society and the environment for which a company is not held accountable for. Now, let us see a few applications of environmental accounting. First and foremost, capital budgeting. Inventory and quantification of environmental costs, allocation of project environmental costs and benefits, usage of appropriate financial indicators, and setting reasonable time horizon that captures the environmental benefits. Next is application of environmental accounting to process and product design, which includes environmental issues that requires analysis. A. Consider environmental costs and performance in defining scope of design project. B. Establishing baseline environmental costs and performance. Then add additional environmental requirements to design criteria and evaluate alternate design solutions by taking into environmental costs, performance, cultural, and legal requirements. Lastly is environmental accounting to cost allocation, in which determination of scale and scope, identification of environmental costs, quantification of set costs, and allocation of environmental costs to a responsible process, product, system, or facility.
All in all, material flow analysis and environmental accounting complement each other. Companies are incentivized to conduct it if they want to promote sustainability. We hope that our FrameFRIES example have given a clear understanding of environmental accounting and how it complements MFA from a financial perspective. Thank you for watching.